soil mechanics is a part of civil engineering. This subject is also called geotechnical engineering. Civil engineering structures like buildings and bridges carry heavy loads. All these loads are ultimately transferred to the earth or soil below. So the soil should be strong enough to withstand these loads. Bearing capacity means the capacity of the soil to withstand the heavy loads from structures above. Soil settles under these loads. If the settlement of the soil is more, the superstructure above will be distorted. If the settlement is excessive, the superstructure can even collapse. So the soil should have sufficient bearing capacity to withstand these loads without excessive settlement. In civil engineering, the word mechanics is having many meanings. One of the meanings is how the material behaves when it is subject to load. In soil mechanics, we study the behavior of the soil under the loads of the superstructure. The structure of a soil is something like this. Soil is a porous material. It contains the solid pieces, also contains the empty spaces called voids. We can easily see that the soil is a porous material because when we pour water on the soil, it seeps downwards, indicating the presence of voids, though we may not be able to actually see the voids. From the structure of the soil, we can see that the soilids form the strong part of the soil, and voids which contain air or water or both form the weak part. Solids have strength while air has no strength and water also has no strength. So the solids form the strong part and voids form the weak part of the soil. So consequently, the soil becomes a weak material compared to materials like steel or concrete. Hypothetically, if there are no voids, the soil will be as strong as rock or concrete. When we talk of strengthening of the soil, what we mean is we remove the air, we remove the water from the voids and bring the solid pieces together. This is the meaning of strengthening of the soil. Once the voids are reduced, the soil becomes stronger. The meaning of compaction is when we remove the air from the voids and bring the solids together. In compaction, we remove the air. When we remove the water from the voids, that is called consolidation. By compaction or consolidation, what we do is we reduce the voids and bring the solid pieces together. Consequently, the soil becomes strong. Void ratio is the most important and fundamental engineering property of the soil. If you take a soil sample, void ratio is equal to volume of voids divided by volume of solids. If the volume of voids is less, the void ratio will be less and the soil will be strong. If the void ratio is more, that means the voids are more and the soil is weak. So, void ratio represented by E is the most fundamental property in soil mechanics. The weight volume relationships in soils, we have to understand first the meaning of weight. In measurements, we are having three systems of measurement. The first system is called CGS system, second system is called MKS system, the third system is called Systems International. In CGS system, the units of measurement are centimeter, gram and second. In MKS system, the units of measurement are meter, kilogram and second. In CGS system, what we measure is mass. If we say it is represented as grams, whereas the MKS system, the K represents kilogram, which is equal to 1000 grams. Whereas in Systems International, we don't talk of mass, but we talk in terms of weight. Weight is equal to mass multiplied by acceleration due to gravity. So 1 kilogram mass will be equal to 1 into multiplied by 9.81. That is the 9.81 is the value of acceleration due to gravity. So weight of 1 kilogram mass will be equal to 9.81 newtons. Mass density means mass of the material, divided by volume of the same material. So the mass density of water will be equal to 1 gram per cc also equal to 1000 kilograms per meter cube. Weight density means weight divided by volume. The weight density of water will be equal to 9810 newtons per meter cube, or also equal to 9.81 kilonewtons per meter cube. Going back to the structure of the soil, if we take any soil sample, void ratio also represented by E is equal to volume of voids divided by volume of solids. Specific gravity of solids is represented as G. Water content of the sample given the symbol W is equal to weight of water in the sample divided by weight of solids. Now these voids may contain air or water or both. If there is no water, voids contain only air, it is called dry soil. If the voids contain only water and fully of water, it is called fully saturated soil, which means the voids are full of water. If the voids contain part air and part water, they are called partially saturated soils. The meaning of degree of saturation represented as S is equal to volume of water divided by volume of solids. In a dry soil, if these voids the voids do not contain water at all. It all contains air. So in a dry soil, S will be equal to 0 because there is no water at all. In a fully saturated soil, S is equal to 1 because the definition of degree of saturation is volume of water divided by volume of voids. In a dry soil, there is no water, voids contain fully air. So in a dry soil, the degree of saturation will be 0. In a fully saturated soil, the voids are full of water. So volume of water will be equal to the volume of voids. So S will be equal to 1. Traditionally, S is represented as a percentage. So in a dry soil, S will be equal to 0. In a fully saturated soil, S will be equal to 100%. A partially saturated soil is in 3 phases. That is, it contains solids, it contains water, it contains air. A dry soil has got only 2 phases. It contains solids, it contains air only. A fully saturated soil is also only in 2 phases. It does not contain air, it contains solids and water. When we solve problems in the weight-water relations, we always draw a phase diagram. If the soil is in 3 phases, we divide this into 3 parts. If the soil is only in 2 phases, we divide this only into 2 parts. This is a 3-phase diagram. At the bottom, we write solids. In the middle, we write water. Here we write air. On the right side, we write the volume. Volume can be in cc's or cubic meters. On the left, we write either mass or weight. If it is mass, it will be in grams or kilograms. If it is weight, it will be in newtons, or it may be in kilonewtons. So a partially saturated soil will have 3 phases. This is a partially saturated soil. It is in 3 phases: solids, water, air. This is a partially saturated soil. A fully saturated soil will have only 3 phases: solids and water. A dry soil also will have only 2 phases: solids, air. At this stage, we will solve a simple problem. It is given that the soil is saturated. The first thing that is given is that the soil is saturated. It is given specific gravity of solids, which is normally represented as G, is given as 2.7. We are asked to calculate the value of void ratio, which is represented as E. Void ratio means volume of voids divided by volume of solids. We will work out this problem. First we draw the phase diagram. It is given that the soil is saturated. That means the voids are full of water. There is no air. So here we put solids, here we put water. Most of these problems can be solved very easily by assuming that the volume of solids is 1 cubic centimeter. On the left, of course, we can write mass. For convenience, we can write mass, or we can also write weight. But in this problem, let us say for convenience, we write mass. It is given that the specific gravity of the solids is 2.6. This is the specific gravity of the solids already given, which means that its mass density is 2.6 grams per cc. We have already assumed that the volume of the solids in the sample is 1 cc. So automatically, as the mass density is 2.6 grams per cc, the mass becomes 2.6 grams. By definition, the water content W is mass of water divided by mass of solids. It is also equal to weight of water divided by weight of solids. Here the water content in the problem is given as 40%. 40% is the mass of water divided by mass of solids. So here we can calculate the mass of water by multiplying 2.6 by 40%. 2.6 multiplied by 0.4. So that becomes 1.04. So here I will write 1.04 grams. So the mass of water in the soil sample is 1.04 grams. The mass of water is 1.04 grams and the mass density of water is 1 gram per cc, which means that the volume of water is 1.04 cc's. We were asked to calculate the value of void ratio E, which is equal to volume of voids divided by volume of solids. Here we have calculated the volume of voids as 1.04, volume of solids we have assumed as 1 cc. So the value of E becomes equal to 1.04.